Okay, good afternoon. I am Anto Budiarjo. Welcome to Monday Live. This is something that we do every Monday afternoon at 3 p.m. Eastern to try and figure out the future for smarter buildings. Our profiles are listed on mondaylive.org, just in case you're wondering who we are. And just a reminder that views expressed here are personal, not of any company or organization. And do post questions, comments, and other interesting dialogue on the Zoom chat. It's always good when this is interactive. And if you want any of the slides, any of the information that's on the slide deck, it is also available on mondaylive.org. You can head over there and find it. So this being June, we've been talking about the fact that automation is not the same as smart. It's been a very interesting month so far. Let's see if we can keep this going. Our specific agenda today, our normal chit chat, and then we want to talk about automation not being the same as smart in the context of the cloud native way forward. This is kind of what we've been leading up to the last couple of weeks, and then hopefully some interesting discussion. But before that, I'm going to hand it over to Mr. Sinclair for an update from automatedbuildings.com. Ken?
Thank you. I'm glad to have that, Mr. I need that. Lots of stuff going on, that's for sure. We've done a summary of last Monday's session, and we're trying to respond to the too long did not read responses we're getting. So we're trying to do summaries of what we think happened in that Monday Live, and they're getting good reception. Nobody has the time to pick through the hour. Ironically enough, AI is helping us pull some of that together, so that's good. The other thing I wanted to announce is Scott Cochran is not able to go to Tampa. And so, Brian Oswald will be there, and he's taking over the Talent Gap. He's chairing that, and Kerry's involved in that as well. So that's interesting. The thing I wanted to talk about and bring to everybody's attention, I'm not sure that if you've been following the post that Sabine from Google put on LinkedIn, it has kind of taken on a life of its own. I give you the link to it there on my slide. There's, at the time I posted this, there was 208. I think there's several more now, and lots of comments. And what she is proposing, if Google jointly develops a baseline structure and format of building device topology, data sets, and metadata. I better let you guys read it. You do a better job than me. Anyway, you can kind of see where she's heading with that. And also she's talking a bit about some of the stuff we've been talking about. So I think it's a good lead in to our cloud native session today. It's interesting to see the discussion that goes on, and she seems to be gathering a bit of support. And I'm encouraging Kerry, Kerry's in Tampa right at the moment, and she's also on this call, is encouraging her to catch up with Sabine and see how automated buildings and the industry can help her support this standard. The only thing that crosses my mind is if Google starts to take an initiative like this, then all likelihood we will have Amazon and Microsoft doing the same thing. So that there we go. We're looking for some standards and some ways of basically separating the data in cloud native. Then we end up with 3 standards. It's kind of a deja vu. In the old days, we were held ransom by the 3 major control companies, and now we're held ransom by the 3 major data companies. Anyway, I think open to some discussion on that if anybody wants to chitter chatter about that.
I guess the one question is, you know, how does, if they're going to do this, is how does it all fit in with Haystack and all the other things? Because obviously they've got their own ontology as well as other things, and it's does it then, you know, we end up with a couple of standards there, how that gets built into this lot?
Actually, there's a lot of discussion about that on the comments, that.
Right.
And those 108 comments or 108, 116 comments. And Sabine answers a lot of them as well. I don't think any of those standards are gonna go away, but one of the things about, and I'm not sure standards is the right word either. But one of these, whether it's haystack or whether it's brick or whether it's matter, all of them are, because they have a predictable format, it'll be quite easy to write programs to convert. So I'm kind of thinking that some of these standards will be the feedstock for, I think. So I don't know. There's a lot of talking that needs to be done for sure, and that's why we're interested, because we're in the news business, so and information business. So I think there's a lot of information that has to be transferred back and forth.
Yeah, I know Brian Turner's on listening in onto this, but he was trying to get some sort of ontology group getting together as well to try and resolve some of these issues with the 3 or 4 kind of lead ontology standards.
I see Brian Turner is on this call.
Yeah, I know. I was just saying, I think he was trying to get some sort of you know, group together to try and discuss how that could happen, you know, how it could happen between Google, Haystack, Brick, you know, and so on.
Yeah, I think maybe Tampo would provide an opportunity for some of us to try and sort of figure out exactly what this is all about and the implications of it. So I think be a homework assignment for those that are going to Tampa.
And there's a comment by Brian to picking up on which is running through my head. It's only the data owners who can contribute to this, right? So that means folks like Honeywell, Johnson, Siemens, Schneider don't own the data, right? It's the building owners who own the data.
Yeah.
So how do you reach out to those folks?
Well, I think there's a lot that we don't know. I think there's probably more that we don't know. So
Sure.
let's bring it back. I mean, next week will be after Wilcom, so we may have an update. So we'll bring it up again next week. Hello, Tracy. Okay, so moving on to Tampa. Rick, do you want to speak to this?
Sure. It looks like the session is oversold, as we warned everybody about. It will be live streamed, and odds are there's some double registrations and overbooking, typical of like an airline or whatever. But there will be a live stream. I believe we've got that link on here.
It's right here.
There it is. Oh, that big YouTube thing.
Yes, where it says live stream.
So
Click on it and you get to that.
As I get older, I can't see quite as well.
I'll put this in chat.
So, and the theme about you know, automation is not equal to smart is becoming, yeah, it's a little bit controversial, as we've said before, but that subheading of, you know, when data is invisible, smart buildings don't exist. Not just invisible to AI, but invisible to any kind of decision-making tools. So that's what our theme is about. It seems to be resonating with people. They're signing up, and we look forward to presenting it. Now, in today's Monday Live, you're getting a sample of what one of the sections of the show is about. So invite participation today, and look forward to seeing y'all tomorrow or Wednesday.
After tomorrow.
Day after.
Okay.
Right.
And our link board as normal, nothing new there. Any other thoughts before we move on? Hearing nothing, let us move on to automation is not the same as smarts.
So, Anto,
Yes.
I want to catch you up on this not equal sign. I'm having a problem with it.
What's the problem?
Well, you called me out the other day. I was thinking back on this when I was talking about that, and I was saying automation is not smart, so it's not equal to. So is the statement is not equal to, is not? what does the not equal, what does that not equal sign represent in your head?
The process of automation and the process of smarts are not the same thing.
Okay. So the
And
not equal
so
sign
smarts, yeah, so smart isn't just automation done a little bit smarter. Automation is automation. Smart has another dimension of intelligence, of not just doing things repetitively, which is basically what automation is about.
So is the statement around the right way then? Or should it be, see, a not equal sign means that the two things are not equal to each other.
You could put it the other way around.
Yeah. So isn't it more accurate from a mathematical perspective to say smarts is not equal to automation?
Yeah, well, thank you, engineer Anno.
Well, it's semantics here. It's words.
Yeah.
We're meshing up words and maths.
Yeah, I think this actually came up 2 months ago in a session when we were talking about AI.
Right.
And it actually came from David Knipkamp that sort of went down this path, because he's been doing automation, the control systems. Obviously he makes controllers, he makes and sells controllers, and he made this point. Just doing automation isn't really the same thing as doing smart. So the two are not equivalent. And we've just sort of taken that to the next level. And maybe in doing that, ruining some scientific detail that you're picking up. So live with it.
I guess it could be said automation is part of smarts as opposed to its entirety.
Thank you, Roger. That's kind of where I was coming.
Okay.
Okay.
It's not an absolute. Maybe. I don't know. I'll let it go.
Yeah. Right. He's letting it go.
I
Let us move on.
until Wednesday.
Well, yes. Okay. All right. So this is the flow that we've been following this month. The first week we've been talking about understanding the problem. Anno was driving that session as I was having travel problems on my own. But anyway, so that was a good session. And then we followed up with what the criteria would be to solve this problem that we just identified. And then today we're going to move forward and say there is a cloud native way forward of looking at this solution. So just a reminder of the last couple of weeks, these are the problems that we identified. Consensus, what smart building means, actually refers back to the whole sort of discussion about automation and smart, but let's not go back there. The silo problem that we talked about, the proprietary sort of way that things have been done has sort of been making life makes life hard and expensive to extract data out of it. This whole sort of notion that the world is now data driven, and yet in real estate it's really difficult. It's mostly unavailable, and so there's a lot of value in this that's untapped. And I'm going to let Rick just sort of say this last point, sort of the penultimate point.
Look, which one? The consent. So my screen shows the consensus one. Okay, good.
Yeah.
Yeah, and that's where rather than debating, well, we know the inevitable interoperability. We know that owners want that. And what we as an industry have the opportunity to do is come together around creating a consensus versus fighting amongst ourselves, because the owners and people are looking to try and get on with making better decisions. Talk about that more later. Need to see that we are solving the problem of the data interoperability and system interoperability. So that's what we're talking about on Wednesday for sure.
And it's time for us to do this now. So this is kind of the what came out of that first Monday in this month. Last week we talked about the viable solution, what the criteria would be. This is basically the list. It needs to be easy to adopt. It needs to be valuable for all underlying their stakeholders, big and small. Making silos interoperable is really the key objective, technically perspective, for it to be open, standardized, and secure, and to be AI fluent. And lastly, to be cloud native. That's kind of what we came at last week. So what we want to talk about this week is the cloud native way forward. And the way I'm actually going to do this is I'm going to jump a different slide deck, which actually has the same words in it, but this is the slide deck that I'm actually going to be using in Tampa in a couple of days. So what do we mean by this cloud native way forward? So obviously to address the problems that we talked about. So sort of the most important problem from a structure perspective is this issue of silos. And this is how we tend to think about this problem. An asset, a building is a large asset, complicated asset, is made up fundamentally of these silos. And in many ways, we've tried for many years, for decades, to do integrations across these silos, talking between, let's say, HVAC and energy and lights and CMMS. It's doable, but it's really hard because each of the silos typically have their own protocols, their own best practices, their own way of doing things. And building owners, asset owners, employ people in the HVAC silo to do HVAC, right? So it is actually quite reasonable that they're going to do HVAC and they don't really know about anything else. They don't really know about anything else in other silos. It's this whole sort of Iowa thing that if you're in a silo, you don't know you're a silo because the whole world is that silo, right? So this is reality that we are living in, and it's been very, very difficult to make integration, especially when you say you want to be able to integrate, or you want to make data flow between any of these silos with anything else, right? It's really, really difficult because there's no model of doing that. So the way we are approaching it, and obviously this is sort of an IBB approach, is that we create what is essentially a cloud native abstraction of each and all of these systems in these silos that require to have cloud native interoperability assigned to them. So these are kind of the abstractions, and we'll actually see how this works. So each system would have an abstraction that is cloud native. So at this point, all of these things behave in the same way. They all behave in a cloud native way. Right. So by doing that, they can then interact with each other using these connections, which are depicted here by the blue lines. Because at this point, at this sort of cloud native layer, they're all the same from a technical perspective, from a protocol and interaction perspective. This is the mechanism that we use to make silos interoperable. But this has a fundamental problem in buildings today, because not many of the silos that are in buildings have this sort of cloud nativeness in them, right? So it's because each system typically has its own way of connecting to the cloud, if it talks to the cloud at all, or the internet, right? So that's kind of the challenge. And that is essentially the problem that the IBB was designed to solve. The interoperable building box, which is a piece of open source software. That's role is to build, to bridge the building, which is depicted here, with the cloud. That's its role, is to bridge this, right? It is fundamentally a piece of software that's going to run on a device or in a virtual environment in the building, but it's always on-prem. In other words, it's always on-prem, and therefore it always has good networking, low latency, good reliability of networking in the building, which is one of the challenges with sort of cloud from a field bus perspective. Right? The IBB also runs Docker containers and other containers, so it can be expanded to have applications do other things, such as application services, data storage, and so on. So the whole idea of the IBB is to make the building cloud native, because by having this building here, you look at it from the top. If you're looking at it from the cloud, it looks just like another cloud resource. It looks just like a Google piece of cloud or an Amazon or anything else. It looks the same, and all buildings will basically look the same. That is the reason why the IBB makes the buildings cloud native. And this is another way of sort of looking at this. This is a depiction of how the IBBs get managed. They get managed by cloud management platforms, singular or plurally. And it's always in the cloud. And there is an interface mechanism between the platform and the IBB itself, each of the IBB itself, which is obviously another open interface that's been created. So this is how everything works. So what I'm going to go through now is just the mechanism, how the IBB actually works. So this is an IBB in a fictitious building connected to the cloud. And let's say that this IBB has a number of applications. It has a BAS application connected to BACnet, let's say, and it has some IP based controllers, and it has IoT connected to directly to the cloud. So when an energy AI bot comes along, is being installed, what it does is it makes this declaration. It says, I can consume energy about Acme HQ. So this is me verbalizing what the declaration will be. In reality, it will be a technical sort of standardized way of doing that. It makes that declarations to the IBB, to the broker that's inside the IBB, and the IBB, the broker, then says, okay, you can consume energy about Acme. This guy can provide it. This guy can provide it, and the IoT can also provide it. So these blue lines, these connections are established by the broker automatically, as and when this energy AI bot is installed. That's how it works. It just does it. And this whole thing is dynamic, which means that if something else were to be introduced a month later, for example, a month later, there's another application that's been installed so the utility can connect to this IBB. And that also has some data about energy data about Acme HQ. When that is installed, this line is automatically created for the energy for the bot. So everything gets connected and disconnected dynamically as and when things change. It's kind of the nature of how the IBBs work. So if you look at this, another way to draw this is this. Is this diagram that I had before, right? These are the silos that I'm depicting here, right? They're being abstracted to the cloud native in the way that they are being brought into the IBB. That's sort of part of it. That sort of by bringing it into the IBB, by making these declarations to the IBB broker, it's effectively saying, I'm cloud native in this manner. And it's that information that the broker uses to establish these connections between all of these different systems. Okay, so far? I am going to jump in to show how this works. And what I'm going to do is bring up an application called IBB Zone, which is a reference cloud platform that we've created for the IBB. It's a tool that can be used by anybody for free to test and develop IBB applications and IBBs themselves. And what I have in my IBB Zone is an area that I call My Buildings that I've been using to test the installation of a number of buildings. And what I'm going to go to is actually this one here, the Fior building. I'm going to open it up. So this is a building. And what we have actually done, the last sort of set of sort of really interesting stuff that we've been doing is that to pull in all of the information about a building, and this is one of them, from a BIM model. So this is a building that was created in one step, and if I have time, we'll show you how that's done. And it brought in the fact that there is a floor 2, and this is the floor plan of the of floor 2 with all of the pieces in it. Right, so that came from the BIM model. Floor 3, interestingly enough, for this model has nothing on it. Presumably they're working on it, or is, but that's what's in floor 2. Floor 1 has a whole bunch of other things. Right, so all of those floor plans were brought in from the BIM model, and what we've been able to do here is to then extend that. So if this is floor 1. I was able to install a more detailed application right? Which again was using the BIM model. It went out to say, okay, I'm being installed in floor 1. Let me go and get all the information from the BIM server of floor 1, and that's what it brought in, right? And in this case, because it is the detailed version of this is kind of just a simple floor plan. It has a lot more information in it. And you can actually see if I scroll into it, I can actually zoom into a component this is actually a chair, and you can actually see the chair. This is that type of chair. All of this is coming from the BIM model, the attributes, and you can even have attachments and other informations. All of that's in the BIM. If you look at this one, it's got that, it's got an attachment, and it has the message that I typed in earlier today, this chair is broken. And everything that exists in the BIM model is brought in to this view, right? And this is kind of where we got to so far. And what we obviously want to do is we want to then go deeper, because we're anticipating the components that we'll see in the BIM model will be components of mechanical equipment components, chillers and VAVs and whatever, right? We typically don't see that in BIMs because they're not put into the BIM model, is my understanding. But if it were there, it will be visible right here. Let me just go around a little bit more, and I'm going to open it up because I know Rick has some comments. If I go up to the building itself, so this is up on the building itself. I was also able to add in a CMMS on this page, because this is a CMMS coming from it's a thing called BIM Genie. So this CMMS is again also relating to this building, right? And because we think about IBB, there's an IBB in this building, and this is the representation of the IBB. It's there and it's online, and you can even see the OpenADR app, which is the app that comes from Skycentrix. This app is actually running in this IBB, right, in that building. Obviously, this is a fictitious building, so it's actually, but it's there in the cloud somewhere. And Pete even sent me earlier today an example of how you would actually bring in data into a spreadsheet, into something like a FCI calculator. So what we're really sort of doing here is bringing, starting with a framework based on BIM, because it is what the building is. It is the structure of the building, and then overlaying information one after the other. And I want to stop and let Rick comment on some of this.
Yeah, the exciting thing about that and that demonstration isn't that we brought in a floor plan or we brought in certain data or the facility condition assessment spreadsheet or data. It's the fact that all these different systems are using, to me, it's about the fact that they're all using a very consistent way of being brought in. So all these different siloed apps have been modified, or these data sources have been modified to be IBB compatible. And that's the story, or to use these cloud native ways, as our subject for today is, to use a cloud native way of becoming consistently therefore loadable into the IBB, so that now we have all the data available to do the digital twin stuff, make smarter decisions, run AI on, but it's all about the consistent way that the systems can now be made available to that building or to that decision-making about that building. And that's what we're excited to be able to show. These different vendors have modified, or we've modified them for them, or I don't know, we've modified their system to be able to be brought in to one, to one view, one decision-making platform, the IBB.
And just I wanted to show one other thing. I'm going to floor 2 here, where there are no other tabs here because I haven't installed anything. What I'm going to do is to show how you install something and where it automatically sort of knows where it is and automatically displays stuff. So I'm going to install something on floor 2, and I'm going to select the BIM apps, and I'm going to select this one here. It's called the Onuma plan, and I need to give it a name. It'll ask me for a name. I'll give it details. And I install that. And now you have floor 2. This is the original floor 2 floor plan. This is the detail that I've just installed. So it knew where it was, and it's displaying the detail of floor 2.
And just
So
to
you
highlight on the mechanical, what you said about mechanical, if the mechanical systems, and it looks like on the left, there is actually probably some mechanical systems, but without having to go show it, what we're also doing, because everything's going to be, you know, consistently connectable in a consistent way, bringing in BAS data or live temperature sensors, IAQ sensors, occupancy sensors will all be brought in the same way, with that consistent way, that cloud native way. And so therefore the information about the chair could just as easily be information about an IAQ sensor or the status of an air handler.
There's some interesting questions in the chat there, Anto, you might want to take.
okay. I'm actually sort of done in terms of showing what's possible here. I wanted to hand it back to. Let's look at some of the questions.
Start with actually the one that triggers me is the question from Cyril about the disconnect between BMS systems data versus BIM data.
Ooh, a softball.
That's awful.
Greg, do you want to take that?
I don't see the question yet, but the
problem is owners are not in harvesting that AEC data because there is no common data structure for the AEC teams to use.
so that's being solved. That's one of the reasons we're excited about what we've learned over the past couple of weeks about, you know, what's been going on over in the world of architects and engineers. Kimon Anuma is actually on this call. He'll probably talk a little bit later about all the progress that's been made relative to the standardization of the data that used to be really, really proprietary over in the, you know, design world. And there's, for those who haven't looked it up or learned a little bit more about it, this concept of IFCs and the work that's being done. David Wiltz has talked about it. The work that's being done, and they're, you know, like in a 4th revision now of standardizing how the different components that make up a building or the design of a building are named. And that's huge because it's sort of releasing the captive components that make up buildings, and whether it's geometry or it's the specific pieces. I don't speak about it as well as someone like Kimon does, but we're excited to be able to see the progress that's been made in the normalizing of how components are described in BIM. And with the intent is that then all those components can then be put across a life cycle analysis. So it's not about just how the chair was built or what the warranty of the chair is, but or the mechanical systems or anything else. It's about how that changes over time. Because as we know, BIM is 3D, but it's actually not. It's 4D, which includes the element of time. So we're set up to be able to integrate our data into a BIM model or vice versa much more easily. Owners have been dreaming of this for decades, and one of the reasons we're showing everything in a BIM model is because we're saying, hey, with the advent of cloud native computing, with the progress made by IFCs, we can now think that this is something that's reasonable to do without breaking the bank.
So to question from Mike about, is this real time? This is real time. There's no cheating going on here. I can just pick any space here, and I think I can do the same thing. I can install a plan for that and give me the details for that space only. Not sure there's much in it, but there you go. The chair, and computer, etc.
Anto, I think you on one of the slides, or back a couple of slides, is where we're showing that we are doing work with building automation systems, and we're looking forward to bringing in data from building automation systems. And people that are working on these committees are, very BAS centric. It's just we haven't quite gotten to where we can show, stuff from Ingenuity or from.
So let me just do one thing, and then we'll move on. On wherever it was that I was in. I remember where I was in. I'm going to install another thing here. You notice that there's a OpenADR that is a server. I'm going to say that this mechanical piece of equipment has installed in it in the IBB a NanoEdge system, ISMA, that has this capable of talking demand response. Right? So I'm just going to install that, and I install it again. Let's finish the installation. Now there is a NanoEdge, which is actually an incomplete product, so you're not actually going to see the UI here. But what you'll see is if I go to show the graph of what's going on behind it, this NanoEdge has actually been is now talking to the OpenADR server that's in this building. So if I go back to the Fjord building, and if I go to OpenADR, it will actually see now that OpenADR is talking to 2 NanoEdges. There was originally 1. I should have called it something different, but that's how the connections happen again, very fast. So all of this is cloud native. Rick, you want to?
Well, yeah, if we haven't said it often enough, is the next slide the cloud native? Okay, so for those not familiar with the concept of cloud native is a function of the Linux Foundation, and there's currently, it looks like 1,100. I'm not going to count them all, but it looks like there's about 1,100 projects underway that are paving the way for how these connections use a consistent approach to communicate, for whether it's for messaging or data, or et cetera. But there's literally thousands of different projects underway, and we will be counted as one of those projects. The main thing about that is that the methods for the development of the IBB is supported by all the work that's being done by all these other CNCF projects. And under CNCF is 850 companies, 200,000 contributors. There's a lot of work being done to show how to modernize the connection between systems of systems. All sorts of different domains, but fundamentally the code and the methodologies it's a path that's being well paved. So we feel comfortable attaching, what we're doing to this cloud native computing foundation, CNCF, with the air cover of Linux, because CNCF is a significant part of Linux. And that's helpful in terms of the credibility with the IT departments. It's helpful in terms of when you get your developers or your project managers to understand there are proven ways to do this. And when we talked about making those different apps more cloud native compatible, and therefore a consistent way to be able to bring them into the IBB, again, we're following the path that's been paved by these 200,000 people that have gone before us.
And those numbers are actually just for the cloud native CNCF. That the numbers of Linux Foundation is obviously larger because CNCF is just part of Linux. But anyway, big numbers.
This also is, and if you were to look at some of the names that are in there, some of the big names in our industry are already, they're already part of what the Linux Foundation is doing. They're already using cloud native techniques for their back office. They just might not have been, they apparently haven't been thinking of how to make systems more interconnectable, and why. There's some people on this call that constantly are saying we need to understand the why. And this slide is the sort of the setup for the answering the why. And TXO, we've talked about a little bit. Total cost of operations or total risk or total efficiency. The X can stand for anything that we're going to solve for. The point is that now that we've got this consistent way of bringing all those different systems together, where it's condition assessment or maintenance management or lifecycle planning or building automation systems or energy management or demand response, once you have a consistent way to bring things together, you can actually think about using them for higher level decision making. And that's why we're setting up this context of TXO, is that now that we can start to think about making decisions based on data from multiple systems, what are we trying to accomplish? And what KPIs are we trying to make better, or where areas are we trying to improve? So the concept of TXO will be revealed at Realcomm, and we're using that scoreboard because what we're talking about is trying to establish consistent ways. Now that we got consistent ways of connecting data, let's talk about consistent ways of describing the objectives.
And I think that's it. And I've brought on Kimon. Kimon, welcome.
Yes. Hello.
Maybe you can
Hello, everybody.
introduce yourself briefly and speak to how BIM has been brought into this world, because you're
Yeah.
totally BIM world. So
Thanks very much, and exciting to see all the progress you guys made with the demonstration for Realcomm. So I'm an architect, and we've been using BIM for 30 years, over 30 years actually now. And we built our own application in the cloud actually over 20 years ago. That was the Onema system, which is the BIM server, and also BIM Genie, which you saw there. So we've been kind of focused on getting what's traditionally been in BIM world of file exchanges, exporting files and importing the whole silo thing. And we focused on getting it in the cloud and having the right level of detail to be able to serve it quickly. And that's what you saw with the floor plans. And one point I'd like to make, Anto, is that if the models are formatted correctly and delivered with mechanical systems, then they definitely are part of that. The Fior building is kind of an example of that. But that, interestingly enough, that building started from a JPEG. We basically just started tracing it and building up the model. Other models that you have loaded, like the Collectus building from CDV Systems from Searle, started from a BIM that had actually the requirements in it of what the mechanical equipment should have, what assets should be in it. So the equipment is in there as well too, and that's an important part of guiding the delivery.
While you're speaking, what I think I'll do is I'm going to go to my buildings, and I'm actually going to install another building.
Okay,
just to
great.
show that process.
Yes, that's great.
Oops, not standard. I'm going to install a BIM building. And currently these are manually entered, so do that. So I want to type in 019, and I have a token which I need to do, and I need to do that. And this is going to go and work. So you can current.
Yeah. That's generating on the fly from.
Yeah. And it should, it's like 10 floors, so it'll take a few minutes.
Yeah. Actually, this is the Collectus Tower, is that correct? I think it is, right? Yeah.
Yes.
Yeah, I can recognize it. Yeah, so that's the one that's coming from Searle. So the specifications came in from BIM. Pardon me? Yeah, so it's pulling it in from our server. We use the industry standards like IFC and everything, but the thing that's happened over the years for BIM deliverables, even with IFC, has been about we'll pass over the whole file to the next team. In this case, we're on the server and we're just hosting it, letting it make it accessible to this particular interface here. So yeah,
there's the Collectus, and we have level 10 is mechanical. So let's see what that floor plan looks like. I can install a more detailed view.
And this is all on the fly. Yeah,
it's all on the poor fly.
Yeah. There you go.
This is actually a boiler.
And I think if you go to attribute, yeah, you start seeing some of the attributes. So the more attributes that are loaded in the model, it starts showing up more and more details if it's loaded in. This particular one has a few of them in, but it could be completely loaded as well. And it can be controlled at the server who has access to it. Can you get to the attributes about the equipment, for example? In certain cases, no, you just want to be able to say something's happening with this equipment, or I want to scan the QR code and find information about it. In other cases, you want to go all the way and pull up information, detailed information, including if there was, a sensor attached to it, for example. That's the part that we're interested in. How do we,
And if in collectors we want the CMMS, we just say do that. And in the BIM Genie, I think it's the manager is the one we want. Actually, let's just do the stats. Let's see what that looks like.
done a lot of work here. New stuff I'm seeing here.
But basically, that's the tower itself and all the buildings. And this is from BIM Genie with some stats.
Real-time work orders that came in for that building, which we used for the conference. So if the request came in a few minutes ago, you'd see it here essentially as it's coming in.
So I'm going to stop the share and let's get the whole panel to have a discussion and Q&A about this. Who wants to start?
I think you might want to just describe a little bit more about the IBB piece. Anto, you kind of glossed over that a little.
The actual IBB that's in the building kind of thing.
Yeah, and how that worked and works.
Yeah, so the IBB has been created so that it is managed by a cloud management platform. I keep on saying that, right? And the way you do that is in the cloud management platform using the IBB zone. You're basically creating a representation, a digital twin of the building. And then you're attaching the IBB to that twin, which is the way that it knows where it is in the virtual world. That's kind of cloud native. The IBB itself is physically in the building. And so there's a pairing thing that goes on when you actually install it. That's basically what it is. When I was pointing to the IBB and the Fior building, I think initially, what that is doing is it's depicting the fact that in that building there is a physical IBB into which you can install applications, which is what we did a number of times.
And again, the key there is that the IBB is where cloud native manifests itself or becomes real in the building. And by having the IBB, it gets people's heads around all the different systems, whether it's Pete's data or Kimon's data or whoever's data. When you say that there's going to be this representation of cloud native in the building, it helps to get people's heads around.
I think that was I think I was just kind of stressing that, Anto. I think that it's I mean, you kind of glossed over that, but it's a key point to the whole cloud native piece, right? Is the realization of it is IBB in the building piece.
Yeah, I think in the explanation I just said that's what it is and kind of almost glossed over it too quickly.
Yeah.
So point taken.
Well, and I think it's a significant component of the whole cloud native approach and solution, how it works.
Steve, Roger, any thoughts?
No, I think reaching out even beyond the technical aspect of this, of course, the whole cloud native thing is opening up to access to more experts than actually exist in the building as well, because effectively the IBB and the cloud thing is all a flat architecture to some extent, if you can think of it that way. And then anybody who's offering applications or is involved in it anywhere, it's actually bringing it more you know, if you've got problems, you know, you can call on experts anywhere in the world to look at your reoccurring challenge of whatever's going on in your building that other people can't resolve. And so it's, you know, it's reaching out that kind of beyond just the technical aspect to the commercial side of things as well, to actually say that this is allowing access to, you know, to experts that perhaps wouldn't normally be available to you, as you know, as to help you run your buildings, you know, whatever it is, your portfolio.
That brings to mind the opportunity for innovation. Like I installed that BIM plan, I think it was called, application to show the details 2 or 3 times, right? Imagine that that's a piece of software that some guy or some gal, Fred or Jane, creates to do some fancy analytics or display or something, right? That needs the BIM information, right? So that application that they create can be installed pretty much in every environment. There is a BIM floor because it's designed for a BIM floor. So if there's a BIM floor, it can be installed there, right? So all of a sudden, that person would have been able to create maybe a small innovative application that all of a sudden gets a massive market, because anywhere that there's a BIM floor, it can be installed.
Yeah, think of space management, optimization, all these things, they can just pull on that. It's a separate application or service that could be utilizing the functionality of the BIM.
Did you see Michael's comment? Is that I like the analogy.
HVAC smartphone.
Gosh, well, who thought of that?
Yeah.
Oh, and what is this comment about? Was this set up ahead of time or was that really fast? Oh, goodness. Would we fake something? It
Steve,
really
you've
was.
been very quiet. Maybe it's napping. Thoughts, Ken? Question? Oh, you're good.
Actually, onto one point to make maybe is we didn't show it, but the floor plans that you saw, if we go into the edit mode and change the floor plan even graphically, or move the chair around or move the equipment around, it would show up immediately in the other interface. So it's not just a viewer of a static plan, but it's tied to the actual BIM that you can go and start doing planning exercises with. So it's even to that extent that this is all kind of interconnected to different types of use cases.
Yeah, I just show that my screen just quickly for this, for that.
That quickly gets tied into asset management and stuff like that as well.
Yeah.
So
So
real-time asset management, which is I hope that people are getting the fact that when we bring in the building automation system, whether it's from ISMA or whether it's from Delta or whoever systems or Honeywell, that the really fast aspect of it is, well, how fast do you want it to be?
so this is that same, what floor was that? Floor 2. So this is that same floor. And I can go and edit mode, and what should we
You can
do?
move a chair, change a name, anything really. And just grab a chair.
I'll move this thing down there and save that. And on here, oops, I need to get to the detail. Sorry. Detail is shown
There
that
it is.
moved.
Completely different UI.
All real time. No cheating, Mike.
And that could be moved by a human, or it could be moved by a device, right? You could say, well, this equipment's failing or whatever, or we changed it out, or, you know, there's another piece that was attached to it, or the room changed size, all of that, just data driven.
Yeah, when I was kind of referring about the asset thing and the question about whether it's live data, you can imagine in hospitals where people are looking for certain pieces of equipment or whatever else, that can actually help them with those sort of things too.
there's really beautiful libraries of hospital equipment that is in the Onuma system. But we didn't do a demo of that yet, but
Okay.
again, the consistent way of doing this, following the cloud native approach, that 220,000 people, somebody mentioned this, it's like, there's a darn good chance you've got one of those 220,000 people already in your hospital that's doing some sort of CNCF connection of some totally different domain system. But all that knowledge of how to use Kubernetes, how to use containers, how to do Dapper, how to do those things is consistent with what we're doing with demonstrating these connections with these systems.
I'm installing another app called Devil Fox, which is to do with cleaning profiles and stuff like that. Again, that's getting the data from the BIM. Okay, so we're coming up to the top of the hour. Ken, do you want to do a sort of a wrap up with what you've seen here, or?
Well, I think, yeah, the big thing is getting participation from our industry in, so we can get some of our live data on there as well. Kind of, you know, the BIM information comes from the design side. We need to get more OT information, I believe, in there. Do you have any demos that are more or OT orientated?
Do you have any BIM models that have a lot more interesting mechanical stuff in it, other than the hospitals?
Yeah, we have plenty. In fact, even a decade ago, we had connections through APIs to sensors and building automation systems. So for example, if something triggers it, you can change the color of the equipment, or say what zone of a building this piece of equipment is affecting. All of that kind of, it's just data to us. As long as we have a connection, then especially if you go through IVD, it'd be really interesting.
Great.
And we do have these other vendors that are already working on connection profiles for their BAS systems, and that's, so it's just a matter of time. But we're excited about is that being able to start it with architects and engineers, and then carry it through the life cycle, which again has always been the dream of owners, is to be able to have a consistent system throughout the life cycle.
Okay, so let us wrap the show. Thank you very much. Thanks, Kimon, for all of the BIM stuff, and also for being on the call today.
Thanks for having me.
Perspective. Looking forward to a lot more good stuff, and we'll get a video of this up on YouTube and but tomorrow or the day after. And those in going to Tampa, we'll see you in Tampa.
See you in Tampa.
All right.
Good luck.
Enjoy.
Phil.
Thank you. Bye.
Bye.
Okay, bye.
Bye now.